Hello, friend, and welcome to the Sleepy Meteorologist. Tonight, we're drifting into the highest clouds in Earth's atmosphere, Noctilucent clouds. These ghostly threads of silver light hover at the edge of space, glowing softly above the horizon just after sunset, or just before sunrise. They are so rare, so delicate, that most people will go their entire lives without ever seeing them. But here, in this gentle space we share together, we can visit them. Ethereal and whisper-thin, noctilucent clouds appear only under very specific conditions. They shimmer when most of the world is asleep, when the sun is below the horizon, but still casting its light high into the mesosphere, where these icy filaments live. Maybe your day has been long, or maybe your mind is still gently wandering. However you've arrived here tonight, I'm glad you have. How's the sky looking where you are? If you enjoy these calming meteorology journeys, feel free to like or subscribe, but only if it feels light and easy. For now, let your breath slow, let your thoughts float, let your body soften. Let's begin. As the sun sinks just below the horizon and the world prepares for night, a subtle magic awakens in the sky above. You might not notice it right away. The colors of dusk deepen gradually, soft purples blending into indigo, fading oranges retreating beyond the curve of the earth. And then, something catches your eye, a shimmer, a delicate, silvery blue gleam suspended high above the rest of the clouds. Wisps of light that do not move like storm clouds or swirl like cirrus. Instead, they hover, faint, almost ghost-like, as if the sky itself is dreaming. These are noctilucent clouds. Their name means night shining, and that's precisely what they do. They appear only when the sky is dark enough for most clouds to disappear. But when the sun, though hidden from you, is still casting light far above, that lingering sunlight illuminates these uppermost clouds, revealing them against the deep blue of the twilight sky. Noctilucent clouds are incredibly rare. You cannot find them just anywhere. They are most often seen at high latitudes, closer to the poles, and during the warmer months of summer, when conditions for their formation align just right. But even then, you must look up at the right time, in the right place, and hope the atmosphere allows them to appear. Unlike the cumulus or stratus clouds we see during the day, these clouds reside far above our weather systems. They form more than 80 kilometers above the ground, in the upper reaches of the mesosphere. That's almost the edge of space. At this height, the air is extremely thin, nearly a vacuum, and the temperatures are unimaginably cold, dropping to around 130 degrees Celsius. It seems an impossible place for clouds to form at all. And yet, they do. Their structure is made not of typical water droplets, but of tiny ice crystals. So small, so delicate. These crystals form on microscopic particles, perhaps fragments of meteoric dust, or specks carried upward by powerful atmospheric waves. But it isn't just their composition that makes noctilucent clouds special. It's the light. Because of where they live in the atmosphere, noctilucent clouds are not illuminated like other clouds. They are lit from below. When the sun has dipped just beneath the horizon, its rays curve gently around the Earth, still reaching the mesosphere, even though your part of the world is already in shadow. That sunlight reflects off the ice crystals, bending and scattering softly, casting a glowing blue-white shimmer across the sky. It's a fragile moment, too early, and the sky is still too bright for them to be seen. Too late, and the sun has fallen too far to reach them at all. They are the sky's quiet whisper between day and night. In stillness, they reveal themselves, silent threads of frost illuminated by fading light. Some observers say they resemble brushstrokes on canvas. Others say they look like waves of silk, and perhaps they are both, art and movement, dream and science, suspended in the most delicate layer of our atmosphere. If you've ever watched them appear, you know how it feels. The air grows quiet, the horizon deepens into navy blue, and above it all, a trace of silver, as if the sky has remembered something from long ago. In this chapter, we've only just begun to drift toward them, toward the shimmering veil of night's edge. The noctilucent clouds are waiting, and the sky is whispering. Let's float a little higher, up, and further still, far above the drifting altostratus and the roaming cirrus, beyond the reach of thunderheads, jet streams, and even most weather balloons. There is a realm of quiet cold, a realm where the air is so thin it barely whispers, where temperature drops not by degrees, but by silences. This is where noctilucent clouds live. Over 80 kilometers above the surface of the Earth, nestled at the edge of the mesosphere, these clouds drift where almost nothing else can. The mesosphere is one of the most mysterious layers of our atmosphere. Unlike the troposphere, where we feel the wind and watch the rain, or the stratosphere, home to protective ozone and high-altitude aircraft, the mesosphere lies quietly between worlds. It begins just above the stratosphere and ends just before space begins. And in this place, the air is unimaginably thin. To stand at sea level is to feel the weight of the entire atmosphere pressing gently down on you. But in the mesosphere, that weight has all but disappeared. The air pressure here is less than 1% of what it is on the ground. It's so light, you would need a special suit just to survive. And then there's the temperature. The mesosphere is the coldest region in Earth's entire atmospheric system. Here, in this icy expanse, temperatures can fall to 130 degrees Celsius, or even lower. So cold that water vapor, if it's present at all, freezes instantly onto the tiniest of particles. This is how noctilucent clouds form, delicate crystals of ice built upon microscopic bits of dust or debris. But what kind of dust finds its way this high? Some scientists believe the seeds of noctilucent clouds come from meteor smoke, fine particles left behind when meteors burn up in the upper atmosphere. These particles drift for days, suspended in this weightless realm, until the conditions are just right. Other particles may come from volcanic eruptions, space missions, or even long-distance atmospheric waves that carry material up from below. Once these dust specks are in place, something quiet and beautiful begins. High above, the mesosphere reaches its coldest point, usually in the heart of summer, paradoxically. At these altitudes, the summer pole faces the sun, and circulation patterns drive the atmosphere in such a way that cold air collects in the upper layers. There, in the stillness of this frozen sea of air, water vapor condenses onto the tiny particles, forming the fine ice crystals that become noctilucent clouds. Unlike the puffy clouds we see in the troposphere, these are delicate, thread-like, and faint. They reflect sunlight long after the sun has vanished from our view. And because they reside so high, they are only visible under specific conditions, when the lower atmosphere has grown dark. But the mesosphere still bathes in the scattered light of a hidden sun. To see them is to look not into the weather, but into the very edge of our world. They don't move quickly, They don't roar or flash. They drift. They gleam. They float above the reach of sound, above the pull of weather, suspended in the thinnest breath of our planet's upper air. To imagine this place is to imagine silence itself, a silence held together by cold and height and softness, where clouds form not out of abundance, but out of rarity, out of fragile conditions delicately balanced. This is where noctilucent clouds live, where the sky begins to forget the earth and begins to remember the stars. Let's drift higher still. Now we rise into a place so remote, so hushed, that ordinary weather no longer reaches us. The winds down below have grown quiet. The clouds of the lower sky have disappeared beneath our feet. We are entering a space where clouds are not built from raindrops or warm-up drafts, but from stardust and silence. This is the birthplace of noctilucent clouds. Unlike the clouds we see every day, shaped by thermals, moisture, and pressure, noctilucent clouds begin with something far more delicate. Their story starts with the faint, unseen trails of shooting stars. Every day, thousands of tiny meteoroids enter Earth's atmosphere. Most are no bigger than grains of sand. They streak across the sky, invisible to most of us, vaporizing high above the Earth in a silent flash of heat and light. These are meteors, what many call falling stars. But even when the flash fades, something remains. As the meteoroid disintegrates, it leaves behind a faint trail of dust. These particles are unimaginably small, measured in fractions of a micrometer, and they don't fall quickly. Instead, they linger, suspended high above the Earth in the upper mesosphere, where gravity is weaker and the air is almost still. This lingering dust is known as meteor smoke, and it is here, on this cosmic dust, that the first ice of a noctilucent cloud begins to form. It takes more than just cold to make a cloud in this part of the sky. The mesosphere, despite being the coldest layer of Earth's atmosphere, has very little moisture. But during certain times of year, especially in summer, a small amount of water vapor manages to drift this high. When that vapor meets a particle of meteor smoke, it clings. Molecule by molecule, it begins to freeze. Slowly, gently, an ice crystal is born. At first, it is impossibly small, smaller than the wavelength of light. But over time, more vapor gathers, and the crystal grows. Eventually, hundreds of these crystals form close together, shaping themselves into thin filaments and curling threads. From the Earth, these formations look like luminous wisps, faint silver ripples in the twilight sky. But here, up close, they are assemblies of frozen stardust. Each cloud is not a single object, but a tapestry of icy particles, each one anchored to a speck that once traveled through the cosmos. The very seed of a noctilucent cloud may have begun its journey millions of years ago, long before Earth ever glimpsed its shimmer. There's something humbling in that thought, that the gentle glow you might see one summer evening was born from a shooting star, that the soft silver light drifting at the edge of space is built upon remnants of celestial wanderers. Meteor smoke is not evenly spread. It drifts, gathers, scatters. And so, noctilucent clouds often appear patchy and wave-like, curling and folding like slow-moving ocean currents in the sky. They do not produce rain. They do not roar or flash or pour. They simply exist, gliding at the edge of atmosphere and space, woven from ice and dust and quiet. If you close your eyes, you might imagine them forming now, crystals clustering softly on invisible threads, lit from below by a sun you can no longer see. This is how a noctilucent cloud begins. Not with thunder, not with wind, but with the soft touch of water on a whisper of meteor. Let's follow that shimmer a little farther, into the light of summer. It seems like a contradiction at first glance. Noctilucent clouds form in some of the coldest conditions known in the Earth's atmosphere. Delicate ice crystals shaped in the mesosphere, where temperatures plunge below 130 degrees C. And yet, they are most often seen in summer, when the lower world below is warm, blooming, and filled with long days. But the atmosphere is full of quiet surprises, and this, too, has its reason. To find noctilucent clouds, we must first understand a hidden rhythm, one that begins not on the ground, but far above, in layers of air we cannot feel. While summer warms the surface and fills our days with golden light, it does something unexpected high above. It creates a temperature inversion. In most parts of the atmosphere, temperature decreases the higher you go. But in the upper mesosphere during summer, something flips. The circulation of air caused by heating at the poles begins to rise. As that air ascends, it cools and continues cooling until it becomes the coldest anywhere on Earth, not on the ground in winter, but at the very edge of space during summer. This cold trap in the upper atmosphere provides the perfect cradle for noctilucent clouds to form. The water vapor that rises, ever so slowly, can condense on particles of meteor dust, just as we explored in the previous chapter. But for them to become visible to us, another factor must align. Light. Noctilucent clouds are not bright by themselves. They don't generate light or scatter it, like the lower clouds we see during the day. They depend on just the right kind of illumination, a light that arrives when the sun has dipped just beyond the horizon. And summer is when that twilight lingers. Because of the Earth's tilt, summer in the higher latitudes brings with it long, shallow sunsets. The sun doesn't dive quickly below the horizon. It slides slowly at a gentle angle. This means that even when your part of the sky has gone dark, the sun is still able to shine far above, casting light into the mesosphere, illuminating the thin veil of noctilucent clouds from below. The result? A sky that glows in ways no other season allows. After sunset, as the world begins to cool and darken, faint silver ripples begin to appear high in the north or south. They shimmer, ever so slightly, against the deepening blue. Their movement is slow, dreamlike, not a rush or a burst, but a drifting dance of brightness and shadow. Summer also offers the clearest windows for observing them. The lower air is often more stable. The evenings are warm, inviting us to look up, to linger outside just a little longer. And in that moment of pause, between the heat of day and the hush of night, the sky offers something rare, a message written in ice. These glowing clouds are most visible between late May and early August in the northern hemisphere, and from November to February in the southern. During these windows, observers at latitudes between 50 and 70 degrees have the best chance to see them, but even then, they remain elusive, because noctilucent clouds are not guaranteed. They are gifts of alignment, of season, light, altitude, and silence. And when all of these come together, summer reveals a sky you might never have known was there. A sky above the clouds, above the weather, a sky that only shows itself when the world has tilted just right. As you lie beneath it, let the glow settle over you. You are watching not just clouds, but a season speaking softly to space. Their glow is not their own. Noctilucent clouds shine only because they borrow the last light of the sun, light that has already set from our point of view. These clouds, perched far above the lower atmosphere, are positioned perfectly to catch sunlight from beyond the curve of Earth. And in that soft geometry of angles, shadows, and reflection, something quietly beautiful happens. Imagine the Earth as a sphere wrapped in layers of air. As the sun dips below the horizon, it appears that light has vanished. But in truth, the sun's rays are still reaching the upper atmosphere, bending around the edge of the world. This gentle curve of light continues to stretch upward, brushing against the mesosphere, where noctilucent clouds reside. In this rare window of twilight, the surface below has dimmed and the troposphere has faded into shadow. But high above, thin ice crystals begin to catch that curved light. They glow not with their own brightness, but with a borrowed shimmer. The effect is subtle, silvery, bluish, even faintly gold, and always ethereal. This is why noctilucent clouds are only visible at certain times, too early in the evening, and the sky is too bright. The light scattered by lower layers overwhelms the glow of these delicate structures. Too late, and the sun's rays no longer reach the mesosphere. There is a fleeting interval, perhaps just 30 to 60 minutes after sunset or before sunrise, when the balance is just right. They require contrast. The Earth must be dark, while the edge of space still catches light. This dance of angles is what makes them elusive, and it's also what makes them beautiful. When you see them, you're not just seeing clouds, you're seeing a curve of light extending from the horizon, a path of illumination that bends around the globe. You're witnessing sunlight's final caress, brushing the sky long after it has left the land. The orientation of the observer matters too. Noctilucent clouds often appear in the northern part of the sky for those in the northern hemisphere, and in the southern part of the sky for those in the southern hemisphere. Their shape, their motion, their visibility, all are guided by this interplay between light and position. The clouds themselves are thin, translucent, wispy. Their glow relies on scattering, a process where light bounces off the fine surfaces of ice crystals and spreads gently in all directions. Because these crystals are so small, the scattering favors shorter wavelengths, giving noctilucent clouds their bluish tone. On rare occasions, they may flicker with hints of white or pale amber, depending on the sun's angle and the observer's location. And sometimes they ripple. Waves pass through the upper atmosphere, gravity waves, moving air patterns that rise from storms or mountain ranges far below. These waves disturb the layers of ice crystals, causing them to shift and dance. The result is a luminous texture, rippling like silk, flickering like a distant tide. To watch this is to feel a kind of stillness, as if the sky is exhaling, as if the light is saying goodbye. In the silence of twilight, when birds have quieted and the wind has calmed, the upper sky begins to glow with a borrowed brilliance. And all of it, this entire display, depends on the soft angles of a turning Earth. Light, bending gently, touching ice suspended in silence. Let us drift closer to the poles now, where these clouds linger longest. If you follow the silver shimmer of noctilucent clouds far enough, you'll often find it drifting toward the poles. Above northern and southern summer skies, these clouds reveal themselves most often, gliding in faint, curling patterns across the subpolar horizon. They are a polar phenomenon, tied not only to light and altitude, but also to the unique patterns of air that flow around our planet's high latitudes. But why the poles? The answer lies in a special combination of factors: temperature, moisture, and circulation. During summer, in the high latitudes, the upper mesosphere becomes especially cold. While the surface enjoys long days and midnight sunshine, the air 80 to 85 kilometers above cools dramatically. This cold trap creates the perfect condition for ice crystals to form on particles of meteor smoke. At the same time, atmospheric circulation patterns move moisture toward the poles. This is partly due to what's called the Brewer-Dobson circulation, a slow, large-scale movement of air that carries water vapor from the tropics upward and poleward. Though the amount of moisture is small in the mesosphere, even the tiniest trace is enough. And so, in the polar summer, the mesosphere becomes both frigid and faintly moist. Ice begins to form on high-altitude particles, and noctilucent clouds are born. From the ground, you might see them glowing low on the horizon, perhaps in the northern sky after sunset, if you're in Europe, Canada, or Russia, or the southern sky in parts of Tasmania, New Zealand, or southern Argentina. They often appear in bands or long stretches that ripple and drift. Sometimes they resemble the faintest waves on a still pond. Other times they flicker like silvery flames, rising slowly across the dusk. These movements are not random. Winds in the mesosphere are shaped by tidal forces, planetary waves, and the subtle heartbeat of the Earth's rotation. These patterns cause the clouds to shift and curl and pulse, sometimes stretching across entire continents, drifting from one polar region to another. Noctilucent clouds are also monitored by satellites. Instruments like NASA's AIM, Aeronomy of Ice in the Mesosphere, spacecraft have traced their spread, showing how they change over days and weeks, how they follow seasonal rhythms, waxing and waning with the tilt of the Earth. And yet, they remain ephemeral. Even in the polar regions, they do not always appear. Conditions must be just right. The upper winds must cooperate. The temperature must dip low enough. The sun must set at the correct angle. But when everything aligns, the sky becomes a stage. The polar twilight stretches long and shallow, giving the clouds time to glow. The sun's light curves beneath the horizon, striking them from below. And the cold, quiet air holds them like a breath that never quite exhales. It's easy to imagine them as dancers, slow, delicate, drifting to a rhythm that only the upper atmosphere can hear. Their presence is a reminder that even in the most remote parts of our planet, beauty finds a way to form. It rises out of silence, out of light, out of ice and distance. And so we linger here, over the poles, watching the clouds perform their soft ballet at the roof of the world. Far above the Earth, floating in orbit beyond the atmosphere, satellites keep quiet watch over the shimmering veil of noctilucent clouds. These distant observers are designed not only to capture their glow, but to understand the patterns, motions, and meanings hidden within their presence. Imagine riding alongside one of these instruments, drifting silently over the dark curve of Earth, with sensors trained toward the limb of the planet, where twilight kisses the upper air. From this vantage, noctilucent clouds reveal their full expanse. Satellites like NASA's AIM mission, Aeronomy of Ice in the Mesosphere, use a variety of tools to gently study these clouds. One method involves ultraviolet imaging, since noctilucent clouds reflect sunlight at wavelengths invisible to the human eye. UV sensors can detect their faint signatures with exquisite clarity. even when the lower atmosphere is too dim for us to see them from the ground. Other instruments measure temperature profiles in the mesosphere, helping scientists understand where the coldest regions form and when. With this information, researchers can predict the likelihood of noctilucent clouds appearing based on seasonal and atmospheric conditions. There's also the art of shadow mapping. As the sun moves below the horizon, it casts long shadows through the atmosphere. Satellites can detect these shadows as they fall across layers of air, revealing not just the presence of noctilucent clouds, but their structure, depth, and movement. From space, the clouds stretch like soft ribbons. Sometimes they extend across entire continents, curling and folding in slow motion. Watching them from above offers a fuller sense of their scope, how they pulse, ripple, and sometimes vanish within hours. These observations are not only beautiful, they're also valuable. Noctilucent clouds offer clues about the upper atmosphere's changing conditions. By gently tracking their brightness, height, and frequency, satellites help scientists understand long-term trends, such as shifts in atmospheric water vapor or subtle changes linked to climate. But even with advanced instruments, the approach remains quiet. There is no rush in this research, just steady orbits, long data arcs, and gentle reflection. Satellites don't hear the hush of noctilucent clouds, but they see it. They trace their ghostly trails night after night, season after season, each orbit adding another layer to our quiet understanding. Let's drift now from what we've seen to what we've noticed over time. In recent decades, a question has softly risen into the minds of scientists and skywatchers alike. Are noctilucent clouds becoming more common? Once a rare and polar-bound sight, they now appear more frequently, and sometimes at lower latitudes than ever before. Observers in regions where these clouds were once unheard of now report seeing their silver shimmer on warm summer nights. And so we drift gently into this question, not with alarm, but with curiosity. What might this mean? One of the key ingredients for noctilucent clouds is water vapor in the upper mesosphere. Though only the faintest amount is needed to form their ice crystals, the availability of that moisture plays a crucial role in whether or not these clouds appear. Some researchers believe that increasing levels of water vapor in the upper atmosphere could be linked to human activity. Rocket launches, for instance, leave behind particles and moisture that drift upward. Changes in greenhouse gases may also be subtly shifting atmospheric circulation patterns, moving more water vapor into regions where it can rise to the mesosphere. There's also the cooling effect. While Earth's surface warms due to climate change, the upper atmosphere, particularly the mesosphere, is gradually cooling. This cooling creates more favorable conditions for noctilucent clouds to form, as colder temperatures allow ice crystals to develop more readily. Put gently, the mesosphere is becoming a little more hospitable to their presence. But even as sightings increase, we must remember, these clouds are still rare. They still require just the right combination of factors. They still flicker and fade with the changing winds. And there may be natural cycles at play as well. The sun's activity, for instance, follows an 11-year rhythm of rising and falling intensity. This solar cycle can influence conditions in the upper atmosphere, affecting the brightness and frequency of noctilucent clouds. So, are they growing more common? Perhaps, but the answer is quiet, still unfolding. And while scientists continue to watch, to measure, to reflect, we can simply look up now and then and witness them for what they are, a sign of something changing, a whisper from the upper sky, a thread of frost stretched across a twilight canvas. Between the warm breath of the lower sky and the silence of space lies a region few ever truly see. The mesosphere, a quiet, cold, mysterious frontier. This is where noctilucent clouds form. This is their home. We've visited it before in passing, floating through its boundaries as we explored the birthplaces of these silvery veils. But now, let's pause and linger in this realm. The highest layer of the atmosphere where clouds can exist. The mesosphere begins roughly 50 kilometers above the Earth and stretches to about 85 or even 100 kilometers high. It is a thin, delicate layer sandwiched between the stratosphere below and the thermosphere above. And unlike those layers, which are sometimes warmed by ozone or charged by solar particles, the mesosphere is known most of all for its cold. It is here, in this lofty corridor, that temperatures fall to their lowest anywhere in the atmosphere, reaching as low as 130 degrees Celsius. There is no weather here in the traditional sense. No storms, no rain, no thunder. The air is too thin to support the clouds and systems we know. And yet, in this sparsely populated sky, something intricate is always in motion. Wind patterns swirl in vast, slow streams, hidden rivers of air shaped by gravity waves rising from far below. These waves originate from storms, mountains, and jet streams. As they travel upward, they grow larger, more dramatic, eventually breaking like ocean surf, high above. Their movement causes the air to ripple, and these ripples can gently sculpt noctilucent clouds, giving them their flowing wave-like shapes. Though invisible to the naked eye, these upper winds form patterns, tides, and oscillations that stretch across continents. The entire layer pulses slowly, like the surface of a sleeping sea. And through this calm motion floats ice, tiny, feathered crystals forming on particles left behind by meteors, drifting on currents, gathering silently in the coldest corners of the mesosphere. These are the building blocks of noctilucent clouds. It is a region few have entered directly. Sounding rockets occasionally pass through, measuring temperature and density for only moments before continuing into space. Even most satellites orbit above it. The mesosphere is often called the ignorosphere, not because it is unimportant, but because it is so difficult to study. And yet, this is the place where light bends and clouds glow. This is the place where the sun still touches the Earth after it has gone to sleep. To imagine the mesosphere is to imagine a world in slow motion, where gravity whispers, where molecules drift far apart, where silence is the default sound. This is where noctilucent clouds are born. They emerge not from chaos, but from balance, an exquisite blend of ice, dust, temperature, and light. So, let us float here for just a moment longer. Let the cold embrace of the mesosphere remind us how delicate the upper sky truly is. And when we return to the Earth below, we'll look up once more with new eyes. To witness noctilucent clouds is to witness the sky at its quietest. They do not burst onto the scene. They do not demand attention. Instead, they arrive like a memory, faint, glowing, just at the edge of vision. And with a little patience, you can see them too. The best time to view noctilucent clouds is during summer, especially between late May and early August in the Northern Hemisphere, and November to February in the Southern. During these months, the sun sets at a shallow angle, and the upper atmosphere remains illuminated long after the ground has gone dark. Twilight is the window. About 30 to 90 minutes after sunset, or just before sunrise, is when you'll want to look. This is when the mesosphere still catches sunlight, even though the rest of the sky has dimmed. The lower atmosphere acts as a shadowed backdrop, allowing the delicate glow of noctilucent clouds to become visible. Face the poleward horizon, north if you live in the northern hemisphere, or south if you're in the southern hemisphere. Look low in the sky, just above the horizon, where the last hues of dusk begin to fade. The clouds may appear as pale streaks, shimmering bands, or woven threads of silver-blue light. Sometimes they seem motionless. Other times they drift and curl, like long fingers of frost. Stillness helps. Not just the stillness of the weather, but the stillness of the observer. Find a quiet spot, away from city lights. Let your eyes adjust. Let your breath slow. These clouds are best seen when you are calm, when your attention is gentle, when you're simply being rather than looking. They don't appear every night. Conditions must be right. Clear skies, calm upper winds, and that perfect curve of light from below. But part of the magic is in the waiting, in the anticipation, in the moments when nothing appears, until suddenly something does. Noctilucent clouds do not overpower. They invite. They ask you to linger a little longer. And if you do, you may just see them shimmer. The art of sky watching is not only about what we see, but how we see. Noctilucent clouds remind us that the most delicate wonders of nature often live just beyond our busy hours, waiting quietly for us to notice. So the next time twilight arrives, look up, look gently. You may find that the sky is glowing, just for you. High above the hum of human life, above the chatter of the troposphere and the quiet streams of the stratosphere, lies a region where sound begins to fade. This is the mesosphere, a place not only of cold, but of calm. Here, more than 50 miles above the surface of the Earth, the air grows so thin that sound cannot travel in the way we're used to. There are no howling winds, no claps of thunder, no rustling leaves or chirping birds. Even if a breeze were to stir in this lofty realm, it would do so without a voice. In the mesosphere, silence is not a pause, it is the background. This silence is not empty, it is full of stillness, full of waiting, a quiet vastness that surrounds the tiny, icy forms of noctilucent clouds. Imagine yourself floating here. The earth curves gently beneath you. Stars begin to appear above. The horizon glows faintly with twilight light. And around you, nothing stirs. Not because there is no movement, but because there is no medium dense enough to carry the sound of that movement. This is why rockets soaring through the mesosphere grow quiet as they rise. It's why meteor trails flash silently across the upper sky. Sound waves simply cannot travel far in such rarefied air. Molecules are too far apart to pass the vibration along. In this quiet, noctilucent clouds gather. Their ice crystals drift and align, moved not by noise, but by graceful, invisible flows. Gravity waves, planetary tides, and whisper-thin currents that ripple through the upper atmosphere like threads of motion in a still pond. To be here, in this soundless space, is to feel what the sky feels when it is undisturbed. There is a kind of peace here that is difficult to describe, a peace born not from lack, but from gentle presence, a peace that surrounds rather than fills, that lifts rather than weighs. If you've ever stood beneath a noctilucent sky and felt the world go still, this is the place you are sensing, the silence you are hearing. This is why the clouds drift so slowly, why their glow seems timeless. why their dance feels like a dream. The mesosphere teaches us that not everything needs to be heard to be known. Sometimes, quiet is enough. Let's stay with this hush just a moment more, and then let's explore what gives these clouds their shimmering colour. There is a colour in the sky that appears only under rare conditions. It is not the fiery orange of sunset, not the deep indigo of midnight. It is something subtler, cooler, more elusive. It is the silver blue of noctilucent clouds. When these delicate clouds appear, they glow with a distinctive light, a luminous hue that seems to shimmer between blue and white, tinged with a quiet energy, yet always soft. But what gives them this signature colour? The answer lies in the ice and the light. Noctilucent clouds are composed of very small ice crystals, far smaller than those found in lower clouds. Each crystal measures less than a micron across, about 1/100th the width of a human hair. Because of their tiny size, they interact with light in a specific way. When sunlight, especially from a low angle at twilight, enters the upper atmosphere, it bends around the Earth's edge and strikes these high-altitude crystals from below. The light scatters as it passes through and around the ice particles. Smaller particles tend to scatter shorter wavelengths more effectively. In visible light, shorter wavelengths correspond to the blue end of the spectrum. And so, when these crystals scatter sunlight, the result is a silvery blue radiance. The low angle of the sun plays a crucial role as well. During twilight, the sun's rays must travel through more of the atmosphere before reaching the mesosphere. This filters out much of the red and yellow light, allowing the remaining blue light to dominate. The long path softens the light's intensity, enhancing the glow without overwhelming the scene. It's this gentle geometry, tiny crystals, curved rays, filtered colours, that give noctilucent clouds their ethereal look. The result is unlike any other atmospheric light, too faint to dazzle, too rare to forget. Observers often describe these clouds as luminous ribbons, as sky silk, as faint traces of something ancient brushing the sky. Their colour is often compared to the light of the moon reflected on snow, or the surface of a frozen lake just before dawn. And sometimes, if conditions are just right, they shimmer with a faint iridescence, like mother of pearl, offering flashes of soft greens, pinks, or violets. But the silver blue remains their truest signature. It is the quiet colour of ice meeting light. It is the shade of a cloud that does not belong to day or night, a colour that seems to whisper instead of shine. As you watch the horizon after sunset, and that soft blue glow begins to rise, you'll know you're seeing something rare, something high, something born of light, angle, and ice. There is a place in the sky where temperature reaches its quietest extreme. Not the heat of the sun, not the chill of a mountaintop, winter, but something colder, stiller, deeper. It is the mesopause. This invisible boundary, nestled between the mesosphere and the thermosphere, marks the coldest part of Earth's atmosphere. Here, more than 85 kilometers above the surface, the air thins to almost nothing, and temperatures fall to 130 degrees, or even lower. And yet, it is here, in this breathless place, that noctilucent clouds are born. We float gently now to this quiet threshold. Above us, the air begins to warm again as it reaches into the charged particles of near space. Below us, the mesosphere's icy hush continues to cradle the fragile crystals of noctilucent clouds. But right here, right at the mesopause, is where the balance is most delicate. There is very little moisture this high, but the moisture that is present can only freeze if the air is cold enough, and so this narrow band becomes a zone of possibility, a place where water vapor, drifting upward on slow currents, can finally condense into ice. Here, meteoric dust meets temperature, and from that union, crystals form. In many ways, the mesopause is not a place, it is a condition, a balance between radiative cooling and molecular energy, between what enters and what escapes. From space, it is invisible. From Earth, it is only seen in the glow of the clouds it creates. And yet, this threshold is essential. It is the place where dreams of light and frost begin. To imagine it is to imagine drifting in near silence, with stars bright above, and the Earth's curve glowing faintly below. The mesopause offers no sound, no pressure, no colour of its own. But in this stillness, noctilucent clouds gather and glow. They are delicate echoes of this invisible border, a reminder that even in the coldest places, beauty can bloom. So let us stay for a moment, suspended between two realms, where ice crystals form and dreams drift like vapor in the void. Then let us follow those drifting clouds, as they sometimes wander far from home. Most often, noctilucent clouds are seen near the poles, hovering over Arctic and Antarctic skies, lingering in the long summer twilight. But sometimes, just sometimes, they stray, like a snowflake in spring, like a whisper carried on a wandering breeze. Noctilucent clouds have, on rare occasions, been spotted much farther south or farther north than expected. These sightings are not common, but when they happen, they feel like secrets, a shimmering veil in the skies of Colorado, a glowing thread over Central Europe, a silver ripple seen from Japan or the mid-latitudes of Australia. These appearances are not fully understood, but they remind us that the atmosphere is always shifting, always alive. Sometimes, the circulation patterns of the upper atmosphere carry moisture and dust farther from the poles than usual. Gravity waves, riding upward from distant storms or mountains, can lift the necessary conditions higher into unexpected skies. And occasionally, a solar minimum, or unusually, calm weather below, allows these clouds to form in regions that rarely see them. They arrive without warning. They vanish just as quietly. But for those who look up at the right moment, they offer a sense of awe, a feeling that the sky has remembered something soft and distant, and chosen for one night to share it. Observers at lower latitudes often describe their surprise: a soft light in the north, a strange cloud after sunset that didn't behave like any other, and then the realization that they are witnessing something rare, something high, something normally reserved for polar regions. And with that realization often comes wonder, because if these clouds can appear here, what else might drift beyond its bounds? These moments remind us that even the most delicate of patterns has room to breathe, that even the most consistent rhythms can surprise us with a gentle variation. Noctilucent clouds are creatures of habit, but not confinement. They may belong to the poles, but now and then they wander, and when they do, they gift a new sky to those who've never seen it before. Even here, at the edge of space, water plays its ancient role. Though the mesosphere is drier than any desert, colder than any place on Earth, it still cradles the soft breath of water vapor, a trace presence, a whisper, and it is this whisper that allows noctilucent clouds to form. Tonight, will drift into that delicate process. Water vapor in the upper atmosphere is incredibly scarce. At these altitudes, air pressure is barely more than a shadow of what it is at the surface. And yet, from the tropics and mid-latitudes, tiny amounts of moisture find their way upward. The journey is long, slow vertical motions, seasonal circulation patterns, and waves from below carry this vapor into the mesosphere. Once here, it floats in stillness, almost alone, waiting for the cold to catch it. And when it does, when it reaches the mesopause, that coldest of places, something quiet begins. Water vapor encounters a particle, a speck of meteor smoke, or a dust grain lofted by storms or volcanoes. And upon that particle, the vapor freezes. One molecule at a time, an ice crystal is born. Thousands of these tiny crystals gather. Suspended together, they form a luminous sheet, a shimmer, a noctilucent cloud. And so, in this space between Earth and cosmos, the same force that forms dew on morning grass creates the most delicate clouds known to science. Water has always shaped the sky. It forms the towering cumulus, the falling snow, the fog that clings to hills. But here, it works on a finer scale, crafting clouds from almost nothing, in air so thin it cannot carry sound. Scientists have observed that the amount of water vapor at these high altitudes appears to be changing. Increases in greenhouse gases may be affecting how water moves through the atmosphere. More vapor may be reaching the mesosphere, creating conditions that favor more frequent noctilucent clouds. But even as we study this, the process remains poetic. Water rises, it waits, it cools, it clings. And from that patience, something luminous is formed. It is a reminder that even the smallest things, the tiniest droplets, the faintest traces, can shape the sky. As we float here, held by cold and calm, we remember, water's story is never finished. Not at sea level, not at the poles, not even at the very top of our world. Let us follow that story into another quiet layer, one that overlaps yet remains distinct. In the high latitude twilight, noctilucent clouds become part of something broader. They belong to a larger family of phenomena known as polar mesospheric clouds, or PMCs. Tonight, we'll rest within the soft edges of this category, where names overlap, meanings blur, and mystery lingers. PMCs are the scientific term for what we often call noctilucent clouds. They refer to the same beautiful structures, ice crystals suspended in the mesosphere during summer, glowing in the light of a sun that has already set. But there is a subtle distinction. Noctilucent refers specifically to the visual appearance from Earth, the night-shining clouds we see just after sunset or before sunrise. PMCs include these, but also encompass what satellites observe from above. From orbit, we see the full breadth of these clouds, how they spread, how they drift, how they form patterns across the pole. It's like two perspectives on the same soft veil, one from below, looking up, one from above, looking down. PMCs are studied for their connection to atmospheric conditions. Their size, brightness, and frequency tell scientists about temperature changes, moisture levels, and the flow of air at the top of the mesosphere. Satellites like NASA's AIM mission have mapped them across seasons, showing how they pulse with the rhythms of Earth's climate. And yet, despite all we've learned, they remain elusive. We still don't fully understand why they appear when they do, or why some seasons bring more while others remain quiet. Their connection to solar cycles, to greenhouse gases, to meteor activity is still being gently unraveled. So, in this chapter, We rest not in conclusion, but in wonder. PMCs remind us that science and serenity can coexist, that even the most advanced instruments, peering down from space, are watching something poetic. We give them names, we chart their data, but we also admire. Noctilucent clouds, PMCs, silent veils of ice. They remain the same, quiet, luminous, patient. Let's drift with them still. This isn't weather in the way we usually imagine. There are no downpours here, no lightning, no gusts or gales, not even a whisper of rain. And yet, something forms, something delicate, something we still call a cloud. Tonight, we pause to reflect on the faintest weather on Earth. Noctilucent clouds do not belong to the realm of umbrellas and forecasts. They exist beyond the touch of the surface, far above the jet stream, beyond even the highest mountain winds. In the mesosphere, where these clouds live, air is too thin to breathe, too quiet to roar, too still to swirl. And yet, they appear. They do not build from rising heat or collapsing pressure. They do not darken the sky or bring the scent of rain. Instead, they arrive softly, drifting into view at twilight, like the reflection of something half remembered. To call them clouds is to stretch the word, and yet it fits. They are made of water ice, just like their more familiar cousins below. They form from condensation, tiny crystals clinging to particles in the upper atmosphere. But they do so in a realm untouched by storm systems, unmeasured by barometers. They are weather-stripped to its essence. Noctilucent clouds are reminders that not all weather is forceful. Some of it is simply presence, a shift in color, a ripple in light, a moment of reflection suspended in the air. The atmosphere is a layered thing, and each layer tells a different story. Down below, weather moves fast, winds stir, clouds tumble, fronts pass. But up here, near the edge of space, the rhythm slows. Change happens gradually, subtly, like the unfolding of a quiet thought. And so, we name this faint appearance a cloud. Not because it brings rain or casts shade, but because it embodies what clouds have always meant: transformation, condensation, softness drifting on invisible currents. It is weather, yes, but in its most poetic form. When we look up and see a noctilucent cloud, we are not watching a storm. We are watching a suggestion, a shimmer, a note at the end of a long song. Let us linger in that thought a moment longer. The idea that weather doesn't have to be loud to be real, that a cloud need not fall to be felt. And as we reflect on that, we turn to time, to the briefness of their appearance. Let us drift gently now. Noctilucent clouds are not in a hurry, but they do not linger forever. They form in silence, shine for a moment, then vanish, like breath on glass. Tonight, we'll watch them come and go, and we'll listen to what their brief lives can teach us. These clouds are often visible for no more than an hour or two, sometimes even less. They emerge after sunset, or just before sunrise, only when the balance of light is perfect. And when the sun sinks too far, or rises too high, the light no longer reaches them, and they fade. It begins slowly, a softening of shimmer, a paling of silver blue. The delicate structure begins to blur, then thin, then disappear entirely into the darkening sky. No wind scatters them, no heat melts them. They vanish because their light is gone. They exist in a window, a twilight threshold when the earth has darkened, but the mesosphere still glows. Once that window closes, their stage dissolves. Their story ends, until the next night, or perhaps not again for days. Even during the night, they drift, Carried by slow-moving tides in the upper atmosphere, they can shift across the sky or slide beyond the horizon. Observers may catch them at just the right moment, or miss them entirely. This fleeting nature is part of their mystery. To see one is to witness a perfect alignment of light, ice, and silence. Their lifespan isn't measured in hours, but in grace. In the soft unfolding of a moment, in the brief shimmer that makes us pause and feel small and still. They remind us that not all beauty is meant to last, and that sometimes the most powerful sights are the ones that barely stay. If you ever catch a noctilucent cloud, let it change you. Let it teach you about impermanence, about presence, about the quiet wonder of something that comes only once, then goes. And now, as their light fades softly from view, we follow where they lead next. Let's drift gently into a question as soft and open-ended as the clouds themselves. Are noctilucent clouds new to our sky? Or have they always been there, just waiting for us to notice? It's a quiet mystery, one that invites us not to rush for answers, but to float slowly through time. Noctilucent clouds were first officially recorded in the late 1800s, following the massive eruption of Krakatoa in 1883. In the years after the explosion, skies around the world were filled with unusual twilight phenomena, red sunsets, high-altitude haze, and, it seems, something else. Observers in Northern Europe began noting strange silvery clouds appearing well after sunset, clouds that seemed to glow on their own. This marked the beginning of humanity's awareness of noctilucent clouds. But the question remains, did they truly begin to form then, triggered by volcanic ash and atmospheric changes? Or had they been quietly present for centuries, overlooked because we didn't yet know how, or when, or where to see them? After all, noctilucent clouds are easy to miss. They appear only at certain latitudes, only during specific seasons, and only under very precise twilight conditions. Before electric lights, before widespread photography, and before dedicated atmospheric observation, it's possible they simply escaped notice. Some researchers have gone searching through old journals and artwork, looking for descriptions, for paintings that show twilight skies with strange, shimmering clouds. But the evidence remains inconclusive. Hints, suggestions, echoes of something high and faint and silvery blue. And so we are left with a beautiful uncertainty. Perhaps these clouds are new. Perhaps something in our atmosphere has shifted in the past 100 or 200 years. The industrial age brought more moisture into the upper atmosphere through aviation and rocket launches. Perhaps human activity has contributed to their visibility. Or perhaps we simply started looking up at the right time, with better tools, with more observers, with quiet curiosity. There is a kind of wonder in this, the idea that the sky can still surprise us, that something as delicate as a noctilucent cloud can go unnoticed for most of human history, until the world grows still enough, quiet enough, aware enough to see. In this way, noctilucent clouds invite us to pause, to consider what else might be waiting just beyond the edge of visibility. What else we might discover, not by rushing forward, but by softening our gaze. Some things are not new, they are newly noticed, and there is magic in that noticing. Tonight, we float through time, through changing skies, through the memory of our planet and the eyes that have turned toward it. The noctilucent clouds shimmer above, unchanged and untouched, whether we look or not. But when we do, we remember that even now the sky has secrets, let's carry that sense of wonder with us. Noctilucent clouds are more than beautiful. They are reflective in more ways than one. As they shimmer in the twilight sky, they also mirror something deeper. Subtle shifts in Earth's atmosphere. Quiet changes that are otherwise hard to see. To understand how, let's return to where these clouds live, high in the mesosphere, more than 80 kilometers above the surface. It is here, in the coldest, thinnest layer of our atmosphere, that noctilucent clouds form. And because this region is so sensitive to change, the presence of these clouds offers clues about what is happening in our skies. In recent decades, scientists have noticed a gradual increase in noctilucent cloud sightings, both in number and in how far they extend from the poles. These trends have raised a soft but persistent question: is the mesosphere changing? At these altitudes, the atmosphere responds quickly to shifts in temperature, moisture, and circulation. Even small variations in greenhouse gases, such as methane, can influence the amount of water vapor present. And more water vapor means more potential for cloud formation. So, when we see more noctilucent clouds, we might also be seeing more water vapor drifting to the edge of space. The clouds also respond to cooling. Ironically, while the lower atmosphere warms. Due to climate change, the mesosphere appears to be cooling. This happens because greenhouse gases, while trapping heat near the surface, actually promote radiative cooling at higher altitudes. And when the mesosphere cools, conditions become more favorable for noctilucent cloud formation. Thus, these faint clouds act as a kind of tracer, revealing the delicate balance of energy and moisture in Earth's middle atmosphere. They are not proof of any one thing, but they are clues. Their presence, their patterns, their shifting boundaries. All of these help scientists quietly map the unseen changes taking place above us. To observe a noctilucent cloud is not only to witness beauty, it is to glimpse a living signal, a mirror held up to a part of our world we seldom touch. These clouds don't shout, they don't demand attention, they simply drift, reflect, and remind that even in the thinnest air, even in silence, there are stories being told. As we float onward, let's carry the image of those shimmering veils, twilight mirrors for the invisible shifts of the sky. Sometimes, what we think we see in the sky is not what it truly is. On a quiet evening, as twilight settles and your eyes wander upward, you may notice a shimmer, faint streaks of light high above, glowing with a silvery blue tint. Could it be a noctilucent cloud? Perhaps, but perhaps not. Not every luminous pattern in the sky belongs to these rare mesosphere-born clouds. In fact, the edge of night is full of gentle illusions, tricklings of light and shadow that play with our perception. Tonight, let's drift gently through these mistaken identities and softly explore how to tell one from the other. One of the most common sources of confusion comes from high-altitude cirrus clouds. These clouds, made of ice crystals as well, form in the upper reaches of the troposphere, far below where noctilucent clouds reside. Cirrus clouds often catch the light of the setting sun, glowing with hues of pink, gold, or even silvery white. And while beautiful, they move differently. Their patterns are broader, more flowing, and they often stretch in elongated wisps across the sky. Then there are contrails, the condensation trails left behind by high-flying aircraft. These linear clouds can linger or dissipate quickly, depending on atmospheric conditions. Sometimes they expand and twist in the evening light. taking on a ghostly appearance. If viewed at just the right angle and time, a contrail might seem to shimmer like a noctilucent cloud. But contrails form in the lower stratosphere, and their structure is typically more uniform and direct, like strokes from a fine brush, rather than the rippled silk of a true noctilucent sky. High-altitude haze, too, can catch the fading light. Pollution particles, volcanic aerosols, or desert dust carried across continents can scatter twilight rays, creating a diffuse glow in the upper atmosphere. This kind of glow is less structured, more of a blanket than a thread. And while beautiful in its own right, it lacks the organized ripple patterns and delicate movement of noctilucent clouds. The key to distinguishing these illusions lies in patience and softness. Noctilucent clouds are faint and high. They appear between 76 and 85 kilometers above the surface, almost at the edge of space. They are visible only during twilight, usually from 30 to 90 minutes after sunset or before sunrise. During that window, the sun has dipped below the horizon, leaving the lower sky dark. But its rays still reach the mesosphere, casting upward light that reflects off these icy clouds. Their patterns are distinct: ripples, whirls, and delicate strands that shift slowly. They don't streak across the sky like aircraft trails, nor do they spread like cirrus. They shimmer subtly, like silk caught in a breath of wind. To a sky watcher, there is wonder in all these forms, even the illusions. But there is a particular hush that comes with recognizing a true noctilucent display. It feels quieter, higher, as though you are glimpsing a rare secret of the upper atmosphere. And if you're unsure if what you see might be a cirrus cloud or a contrail, or perhaps something more, then simply observe. Let your gaze rest. The sky will reveal its truths in time. In the world above, not all is as it seems, but every shimmer has a story. Let's rise now into those stories of movement. High above the earth, where the air thins into silence and the stars begin to wink through the veil of twilight, winds still move, but not as they do below. Here, at the edge of the mesosphere, the atmosphere behaves differently. Winds travel vast distances in soft, sweeping arcs. They don't roar or gust. Instead, they drift, long, slow currents that carry temperature, moisture, and trace particles in whisper-like flows. These are the polar mesospheric winds, and tonight we'll float with them. These upper-level winds play a quiet but essential role in shaping noctilucent clouds. Though the clouds form at high latitudes, typically between 50 degrees and 70 degrees, their position, shape, and movement are deeply influenced by the winds flowing through the mesosphere. One of the most graceful patterns in this upper layer is the summer mesospheric jet. Unlike the more familiar jet streams of the troposphere, which form sharp ribbons of fast-moving air, the mesospheric jet is broad, diffuse, and patient. During summer, these winds often blow westward in the northern hemisphere, creating gentle shears that help guide and stretch noctilucent clouds into their signature ripple-like structures. Imagine them as invisible hands sculpting sky silk. These flows also interact with atmospheric gravity waves, oscillations that ripple upward from the lower atmosphere. As storms, mountain ranges, or warm land masses disturb the air below, their motions send waves up into the mesosphere. Here, in the rarefied heights, the waves can amplify and break, much like ocean surf. When they do, they momentarily change the temperature and density of the air. This can trigger the formation or dissipation of noctilucent clouds. A sudden cooling from a passing wave might allow ice crystals to form, or a warming pocket might dissolve them back into vapor. This dynamic dance of wind and wave gives noctilucent clouds their motion. From the ground, you may see them ripple, twist, or undulate slowly. It isn't the clouds moving themselves, but the winds that carry them. And those winds, so far above, are among the quietest weather we know. In polar regions, the structure of these flows becomes especially intricate. The unique geometry of Earth's tilt and the behavior of solar radiation at high latitudes create circulation patterns that concentrate cold air in the mesosphere during summer. This cold core encourages noctilucent cloud formation, and the whispering winds surrounding it keep the clouds suspended, drifting softly along the edges of night. The entire system is delicate, subtle, invisible, unless revealed by the thin shimmer of high-altitude ice. And so we float with these polar winds, along the threads of atmosphere where sound cannot follow, but where motion still lives. Let the silence carry you now. Let the winds cradle you. Far below the mesosphere, deep within the Earth's crust, lies a force as ancient as the planet itself: volcanoes. Though their eruptions can seem sudden and powerful, they also send quiet ripples through the highest layers of the atmosphere. Tonight, we'll trace one of those subtle echoes, how volcanic eruptions, with all their fiery drama, may contribute to the formation of the softest clouds in the sky. Noctilucent clouds, as we've seen, form far above the reach of ordinary weather. But even in this distant realm, the breath of volcanoes can be felt. When a volcano erupts, it hurls more than just lava and ash into the sky. It also releases aerosols, tiny particles and droplets suspended in the atmosphere. These can include sulfur dioxide, volcanic ash, and fine dust. Some of these particles rise incredibly high, carried by powerful convection and atmospheric currents. Most volcanic ash falls back to Earth within a few hours or days, but certain eruptions are strong enough to propel particles all the way to the stratosphere, and in rare cases, even higher. Once these particles reach such lofty altitudes, they can linger for weeks, months, or even years. Now imagine a volcanic plume rising slowly and silently, reaching the upper atmosphere. As it spreads, the ash and aerosols begin to drift, carried gently by winds we cannot feel. Eventually, a few of these particles might reach the mesosphere, the realm of noctilucent clouds. There, the conditions are cold enough for water vapor to condense directly onto these particles. And just like meteor smoke, volcanic dust can serve as a seed, a nucleus around which ice crystals form. These crystals, suspended in the mesosphere's thin and frigid air, may gather and grow into the shimmering filaments of noctilucent clouds. It's a poetic contrast, from deep fire to high frost, from a molten eruption to a frozen wisp. The violence of a volcanic eruption giving rise, months later, to a delicate glow in the summer twilight sky. Scientists have noted increased sightings of noctilucent clouds following certain large eruptions. The eruption of Mount Pinatubo in 1991, for example, sent vast amounts of aerosols into the atmosphere. In the years that followed, noctilucent cloud activity appeared to rise. But, as with many mysteries in atmospheric science, the connection is gentle, nuanced, and still being explored. Not every eruption sends dust high enough, and not every dust particle finds its way into the mesosphere. But when the timing is right, and the air is cold, and the sky is still, the remnants of a volcano may take on a second life, as silver threads above the earth. These connections remind us that Earth is not separate from its sky, that even the deepest tremors can ripple upward, that a single eruption, long cooled and forgotten, might leave behind a trail of particles so small, so light, they become part of a cloud no one can touch, only witness. So the next time you see a shimmering veil after dusk, remember this quiet link: the fire and the frost, the echo of the Earth's breath, floating silently in a world of shadowed blue. High above the clouds we know, even beyond the reach of commercial airplanes, human hands have touched the edge of space. Through rockets and spacecraft, we've entered the mesosphere and beyond. And with each launch, a subtle trace is left behind. In this chapter, we'll gently explore how these traces, sometimes invisible, sometimes shimmering, might contribute to the formation of noctilucent clouds. When a rocket launches, it moves through multiple layers of the atmosphere in just a matter of minutes. In doing so, it releases exhaust, particles, and vapor into the surrounding air. Most of the activity remains far below where noctilucent clouds form. But for some high-altitude launches, particularly those that reach low Earth orbit or beyond, traces of that journey linger in the mesosphere. One of the more curious phenomena is the observation of bright, cloud-like displays shortly after rocket launches, especially during twilight hours. These displays are often mistaken for noctilucent clouds, and while they are not exactly the same, they do reveal something fascinating. Human activity can seed or illuminate structures in the upper atmosphere. The exhaust from rocket engines contains water vapor, carbon dioxide, and tiny particles. When released into the cold, dry mesosphere, this vapor can condense and freeze almost instantly, forming high-altitude ice particles. In some cases, these particles align with the same principles that govern noctilucent cloud formation. Scientists have studied specific instances where rockets appear to trigger the creation of cloud-like features in the mesosphere. These are not true noctilucent clouds in every case, but they do mimic them, both in altitude and appearance. It's a reminder that our technological reach has quietly brushed the same space where nature weaves its most delicate clouds. These triggered clouds are typically short-lived. They form quickly and fade within hours, but they hint at a deeper truth, that our actions, even at the edge of space, leave echoes. One notable example comes from sounding rockets, smaller launches used for scientific research. These rockets have been intentionally used to study the formation of noctilucent clouds. By injecting small amounts of water vapor into the mesosphere and observing the results, researchers have gained insights into how clouds form, grow, and behave at such extreme altitudes. While these human-triggered clouds don't replace natural noctilucent clouds, they help us understand them better. They offer a controlled glimpse into a normally inaccessible world, allowing scientists to study the interaction of particles, vapor, and light in a setting that is both silent and sublime. It's worth noting that this kind of influence is fleeting. Unlike pollution in the lower atmosphere, these upper-level particles do not accumulate easily. The mesosphere is a cleansing space. What enters it either falls back or is swept away by high-altitude flows. Still, every trail we leave offers a story, and some of those stories drift into silver. As we drift alongside these subtle traces of human reach, let's remember how easily the sky absorbs both the natural and the made. How, even at the edge of space, our presence brushes against the canvas of night. There is a time each evening when the sky shifts, not to full night and not quite still day. It's a tender in-between, a quiet transition where something rare becomes visible. This is the moment when noctilucent clouds step into view, after the sun has set for us, but before its light has fully left the upper sky. Tonight, we'll rest gently in this space between shadows and sunlight, a world where the Earth's curve hides the sun from our eyes, but not from the highest clouds. The mesosphere, where noctilucent clouds drift, lies around 80 kilometers above us. It's so high that when the sun dips below our local horizon, its rays can still reach this thin, frozen layer. As twilight deepens on the ground, a strange light remains above, a glow, soft and silvery, illuminating threads of ice that we cannot see during the day. This glow is not direct sunlight. It's refracted, filtered, and softened by its long path through the atmosphere. At such a shallow angle, sunlight scatters more of its warm hues, leaving behind the cooler blues and silvers that give noctilucent clouds their signature shimmer. This effect can only happen during twilight, the period after sunset or just before sunrise, when the sun is between 6 and 16 degrees below the horizon. Any higher, and the sky is too bright to see them. Any lower, and the light no longer reaches the mesosphere. In a way, noctilucent clouds exist entirely within this fragile window of light. They are not creatures of day or night, but of twilight, of the softest light, of the Earth's curved edge. They require not only altitude and cold, but timing, and so they appear after the world begins to settle, when the birds have quieted, when city lights begin to flicker on, when the hush of evening invites us to look up and wonder. From the ground, they seem almost supernatural, blue-white patterns glowing high above, long after other clouds have disappeared into shadow. Their brightness doesn't pulse or flash. It lingers, calmly, like a gentle echo of the sun's memory. This delayed illumination is why they often surprise observers. You may think the sky has grown too dark for clouds to shine. And then they arrive, shimmering faintly, like frost caught in moonlight. Some people mistake them for auroras or contrails at first, but their light doesn't dance, it drifts, and it doesn't come from within, it's borrowed, reflected light from a sun you can no longer see. This is what gives noctilucent clouds their dreamy quality. They're made not just of ice and altitude, but of perspective, of angles, of timing, of the quiet geometry between a turning Earth and a sinking star. They remind us that light, even when gone from view, still reaches out in soft and patient ways. So tonight, if the conditions are just right, you might see them after the sky dims, after the warmth of the day fades, after the world has grown still. In that hush, they begin to glow. Let's stay in that glow a little longer. The story of noctilucent clouds begins not just in the sky, but in a distant echo of fire. It was the year 1883. Far across the seas, on the Indonesian island of Krakatoa, a mighty volcanic eruption split the sky. The blast was so powerful, it changed the atmosphere. Ash and particles surged high above the Earth into layers untouched by normal weather. In the weeks and months that followed, people around the world began to notice something strange. Unusual sunsets, lingering twilight, a soft, silvery blue glow appearing after dark. These were among the first recorded observations of what we now call noctilucent clouds. But at the time, they were a mystery. Scientists and sky watchers in Europe noted the phenomenon. Letters were written, observatories recorded detailed sketches. The clouds appeared long after the sun had set, glowing faintly in the northwest sky. Some believed they were a result of Krakatoa's ash, scattering sunlight in new and unusual ways. And while volcanic eruptions do influence the atmosphere, this wasn't quite the whole story. What Krakatoa may have done is illuminate something already present, but rarely visible. By injecting vast amounts of dust into the upper atmosphere, the eruption may have created new cloud seeds in the mesosphere, or it may have changed the balance of light in twilight, allowing pre-existing noctilucent clouds to shine more clearly. Either way, 1885 marked the first widely acknowledged emergence of these clouds into public and scientific awareness. Before this, there are no clear records, no mentions in star charts, no sightings logged in maritime journals. It's possible they were truly rare, or simply went unnoticed. After 1885, however, they began to be studied. In the early 20th century, scientists began using photographic plates to capture their faint outlines. Observers described their silky patterns and wave-like structures. Still, their origin remained debated. Were they lower atmosphere clouds, unusually high? Were they auroral in nature, or something entirely new? It wasn't until the space age, when satellites could view the atmosphere from above, that we confirmed their true altitude and nature. But their first appearance was poetic. A sky changed by volcanic fire. Ebul Dambandandum, darkness lit by something new. Even now, when we look at noctilucent clouds, we carry a thread of that history with us. They are reminders of how the sky can hold surprises, how beauty can emerge from upheaval, how something as ancient as a volcano might give rise to a cloud that glows softly in the night. So as we drift deeper into their story, let's carry with us that sense of awe, of a sky changed, of a glow remembered, of science beginning. With wonder, let's keep floating. You don't need a telescope. You don't need a camera or fancy equipment. Just a quiet evening, an open sky, and a willingness to wait. Noctilucent clouds are among the few atmospheric wonders that reveal themselves to the naked eye, but only if you know when and where to look. In this chapter, we'll step outside as the day begins to slip away. The sun sets slowly in summer, especially in the higher latitudes. The sky transitions gradually from golden to rose to lavender, then to deepening blue. As the first stars begin to appear, that's when you begin to watch. Find a place with a clear view of the northern or southern, depending on your hemisphere, horizon. The fewer city lights, the better. Look up, but not too high. Noctilucent clouds often hover low in the sky, just above the horizon, where the last light of the sun still glances across the mesosphere. They will not roar for your attention. They won't swirl or tumble like thunderclouds. Instead, they will shimmer silently. You might see silver-blue ripples, gently undulating like the surface of a lake, or soft bands of light, braided together like strands of silk. They often appear in patterns, waves, whirls, or herringbone textures. Their glow isn't bright. It's more like a whisper of light, a glow that lingers just enough to catch your breath before fading again. They might last only a short time, an hour, maybe two. So it's best to settle in. Let your eyes adjust. Let your breathing slow. Let the sky open itself to you. Observing noctilucent clouds with the naked eye is an invitation to stillness. You don't have to measure anything. There's nothing to record. It's not about collecting data. It's about experiencing wonder. It's about noticing the delicate veil that the sky sometimes wears just after dusk. And because they are so rare, each viewing feels like a gift. Some people go years without seeing them. Others look once and never forget the moment. If you're patient and the sky is kind, you'll begin to recognize their signs. You'll sense the change in color, the silver tint that doesn't belong to sunset or stars. And when they come into view, you'll know. You'll be part of a very old, very quiet tradition. Looking up, waiting, listening to the sky's softest stories. Sometimes, the smallest things shape the grandest scenes. Noctilucent clouds, for all their size and beauty, begin with something tiny. Minuscule particles, smaller than grains of pollen, invisible to the eye, serve as the quiet foundation upon which these high clouds grow. These particles, known as condensation nuclei, provide the surface needed for water vapor to cling to and freeze. Without them, there would be no ice crystals in the mesosphere, no shimmer, no glow. Where do these particles come from? Some arrive from space, fragments of meteors, ground to dust as they burn up in the atmosphere. Others are the byproducts of volcanic eruptions, their ash flung high into the sky, drifting for weeks or months before falling slowly back to Earth. Even human activity leaves a trace. Rocket launches and spacecraft exhaust can loft particles to remarkable heights, briefly altering the upper atmosphere. In recent decades, researchers have also studied the role of pollution, man-made aerosols, that, under rare circumstances, may reach the upper mesosphere. Though far less common than meteoric or volcanic particles, their presence could influence the formation or brightness of noctilucent clouds. Once these particles are in place, the magic begins. High above, in temperatures colder than any place on Earth's surface, a few rare molecules of water vapor find these particles and begin to adhere. Layer by layer, the vapor freezes, slowly building a crystal. It doesn't take much. A cloud that can span miles in width begins with millions of these frozen specks, each one no larger than a virus. And yet together, they catch the twilight light. They scatter it just so. They paint the night with movement and glow. Tiny particles, silent architects of beauty. If you were to hold one in your hand, it would vanish. Too small to feel, too delicate to see. But together, in the thin breath of the mesosphere, they assemble into something you will never forget. In the end, noctilucent clouds are reminders that even at the edge of space, even in the silence between day and night, it is often the smallest things that create the greatest wonders. If you could float high enough, beyond the tallest clouds, beyond the weather and wind, you might come upon something that doesn't look like a cloud at all. It might seem more like a shimmer, a glimmering thread of silver light suspended in the upper sky. And if you could drift inside it, what would it feel like? Tonight, we imagine just that. Noctilucent clouds are the softest clouds in the sky, not in the way of touch or texture, but in their presence. They do not gather in bold formations or stretch across the horizon with drama. They whisper, they linger, they hover where almost nothing else dares to form. They're made of ice, yes, tiny crystals smaller than the width of a human hair. But these aren't the dense, heavy crystals of snow or hail. These are filaments, nearly weightless, formed on specks of dust from meteors, suspended more than 80 kilometers above the Earth, where the atmosphere thins into space. Up here, the air is so rarefied that sound barely travels. The temperature is far colder than any winter day. And yet, this is where the dreamlike shimmer of a noctilucent cloud comes to life. To imagine being inside one is to enter a realm of weightlessness. The crystals are too far apart to block your view, too delicate to cast a shadow. They would not feel cold or sharp. They would feel like light itself, softly diffused, scattered in all directions. You'd see the curvature of the earth below, lit gently by the last rays of a hidden sun. Above you, stars would begin to appear, even as the cloud around you still glows. The sunlight, bending along the edge of the earth, reflects off these high ice crystals, creating their signature silver blue hue. Inside the cloud, the light would feel different. Not harsh or glaring, but filtered, like moonlight drifting through thin curtains. You'd be surrounded by billions of suspended crystals, each acting like a tiny mirror, catching and bending sunlight into soft waves of color. And you'd feel quiet, because in the mesosphere, the wind is minimal. There are no gusts, no turbulence, no storm cells. Noctilucent clouds drift slowly, almost imperceptibly. Their shapes shift not in seconds, but over long minutes or hours, as waves in the upper atmosphere gently ripple through. From Earth, they appear thin and wispy, but from within, they might feel vast and open, like being inside a glowing sea suspended in the air. There's no rain, no thunder, no scent of moisture, just crystalline silence and luminous stillness. To float within one would be to float within a moment. A pause between day and night, a space between Earth and stars. They are called clouds, but they are more like sighs. They are built of the cosmos, shaped by meteors, lit by sunlight, suspended by gravity, and held together by the faint breath of our planet's outer air. And though we may never touch them, never feel their crystals on our skin, we can imagine. We can look up in those twilight moments after sunset and see the dream drifting across the edge of space. The softest cloud in the sky. Let's rise just a little more. Down below, the sky is busy. Cumulonimbus towers, those great thunderstorm clouds, can climb to tremendous heights. Some rise more than 16 kilometers into the sky, their tops flattening into anvils, crackling with lightning and echoing with thunder. These are the giants of the troposphere, the realm where most of our weather lives and breathes. But above even these towering storms, there is another sky, a place where clouds do not roar or flash, a place where storms cannot reach. And there, floating quietly in the twilight, are noctilucent clouds. More than 80 kilometers above the ground, they reside not in the troposphere, or even the stratosphere, but in the mesosphere, a region where temperatures drop to the lowest anywhere in Earth's atmosphere, a place where silence rules. Imagine looking down from such a height. Beneath you, thunderheads pulse with energy, an entire world of weather unfolding far below. You might see the flicker of distant lightning, the billow of storm tops glowing faintly in the fading light. But up here, none of that sound reaches you. None of the wind, none of the rain, only stillness. The light changes slowly at this height. After sunset, the Earth falls into shadow, but the mesosphere remains touched by the last rays of the sun. This is when noctilucent clouds appear, glowing softly against the deepening indigo sky. From this vantage point, they seem like silver filaments, long, delicate waves stretching across the horizon. Their structure is shaped by high-altitude winds, but not the jets and streams that steer our weather. These are polar mesospheric winds, gentle, slow-moving currents that ripple like silk across the upper atmosphere. They are untouchable from the ground. No plane flies this high. No balloon reaches these heights easily. Only satellites and sounding rockets visit this altitude. And even then, they pass quickly, catching glimpses of the clouds in fleeting moments. To observe noctilucent clouds is to look upward and far. They remind us how vast the atmosphere is, how many layers it holds, each with its own patterns, its own silence, its own stories. Storms may dominate the lower sky, but above them there is peace, and above that peace, a glow. The contrast is beautiful. From the chaos of thunderstorms to the hush of space's edge, the journey of looking up is like climbing from noise into a lullaby. Noctilucent clouds mark that lullaby's highest note. Let's linger in that silence a little longer. Noctilucent clouds do not demand your attention. They do not roll in like storms or paint the horizon like sunsets. They wait, softly, quietly, hovering at the edge of the sky, visible only to those who choose to look up and linger. Tonight, let's reflect on what these faint, silvery clouds reveal, not just about the atmosphere, but about ourselves, about our curiosity, about our yearning to understand the quietest parts of the world. Because to notice a noctilucent cloud is to be still, to step outside not for a show, but for a whisper, to catch a moment that most will never see, simply because they didn't think to look toward the twilight sky. They reward the patient, the gentle observers, the ones who know that beauty sometimes lives in faint outlines, soft ripples, and brief appearances. Noctilucent clouds are, in many ways, reflections, not just of sunlight, but of wonder. They remind us that discovery is not always loud or groundbreaking. Sometimes it is subtle, glimmering just beyond the visible, waiting in the margins, drifting in the quiet. Scientists study them with instruments, of course, satellites that measure their temperature, shape, and altitude, ground cameras that track their movement across polar skies, sophisticated models that simulate the thin, cold air of the mesosphere. But long before there were satellites and sensors, there were simply eyes, human eyes, peering into the evening sky, noticing something unusual, something glowing where no cloud should be. The very first recorded sightings of noctilucent clouds in the late 1800s came not from data, but from awe. People writing in their journals, sketching in notebooks, trying to understand the mystery of clouds that shone in the night. This is the root of all curiosity, the quiet act of noticing, of pausing to wonder. Noctilucent clouds teach us that not all questions are answered quickly. Some take decades, some remain open, some invite us simply to keep looking. And as we do, we come to understand something deeper, that the sky holds more than weather. It holds the memory of meteors, the breath of ancient air, the shimmer of light that traveled a long, curved path to meet us. To appreciate these clouds is to appreciate nuance, to learn that the most delicate things often carry the most meaning, that our relationship with the sky is not only scientific, but poetic. So the next time you find yourself outside at dusk, glance upward. You don't need a telescope, just time and a little stillness, because sometimes the sky answers softly, and sometimes that's enough. Let's drift now to where those clouds live, in the space between worlds. Float with me. There is a place above us, where the wind no longer roars, where clouds no longer bring storms, and where the sky begins to forget the earth, and begins to remember the stars. This is where noctilucent clouds drift. Tonight, we pause in that quiet realm between Earth and space, a boundary not drawn in sharp lines or sudden shifts, but in stillness, in temperature, in silence, in softness. The mesosphere is that liminal space, too high for weather balloons, too low for satellites, a realm few have ever touched. Here, gravity still has its say, but it speaks more gently. Here, molecules are rare, and the air is quiet. Here, ice crystals form not from storms, but from whispers. And floating within this hush are the Noctilucent clouds, held between two worlds. Below, the troposphere churns with the warmth of the sun, the weight of storms, and the breath of seasons. Above, the thermosphere glows with auroras and solar winds. But here, in between, lies a narrow zone of equilibrium. Neither weather nor space, just calm. From this altitude, if you could stand still long enough, you would see both night and day. The curve of the Earth glowing in faint outlines, the stars just beginning to pierce the dark, the lower clouds now hidden in shadow, and above it all, the silent shimmer of Noctilucent light. In this place, the passage of time feels slower. There is no urgency, no sound, only drifting. This boundary layer is not just a region of science, it's a feeling. The feeling of watching something ancient move in silence. The feeling of being small, but not insignificant. The feeling of belonging to something vast and graceful. Astronauts, from even higher above, have described the Earth's atmosphere as a thin, glowing ribbon. Makulad, fragile veil wrapped around a dark sphere. And they're right, but few layers are as delicate as this one. Noctilucent clouds are the lace of the mesosphere. They are a trace signature, a shimmer of breath where the world ends and the universe begins. To rest in this space, even just in imagination, is to rest in transition, not just of place, but of thought, between science and story, between earth and sky, between what is known and what is felt. And so we float, held in that thin hush where clouds drift with no storm, and time glows silver at the edges. Let's stay here just a little longer, before we move on. Noctilucent clouds are not permanent fixtures. They do not linger like mountain ranges, or flow like rivers. They come and go, seasonal, ephemeral, and softly shifting with the rhythms of the upper sky. Tonight, we'll drift through time with them, watching as they appear, evolve, and recede like breath upon glass. These clouds favor the summer months in polar regions, where the mesosphere becomes just cold enough and moist enough for ice crystals to form. But even then, their patterns are never exactly the same. Some years bring vibrant, frequent displays, while others offer only a handful of pale sightings. This variability invites gentle wonder and questions. What causes these shifts? Is it simply the natural ebb and flow of atmospheric conditions? Or is there something deeper? Scientists have been watching. For decades now, satellites and skywatchers alike have been documenting the appearance of Noctilucent clouds. Over time, they've noticed a trend. These clouds are becoming more common and sometimes more vivid. Not just at the poles, but drifting slightly farther south, reaching latitudes where they were once unheard of. This has led to a quiet theory, one that connects these glowing veils to larger changes in our planet's atmosphere. The presence of water vapor at such high altitudes may be increasing. Greenhouse gases like methane can contribute to this, creating more opportunities for Noctilucent clouds to form. But nothing is certain. The data is soft and delicate, like the clouds themselves. Each season adds a new thread to the tapestry. Each year, another piece of a slow-moving puzzle. And so, these clouds become not only something to admire, but something to observe, gently, patiently, without rush. Their glow, after all, is light scattered by tiny ice crystals, but the pattern of their presence may be light scattered by time, reflections of deeper, subtler shifts high above. We can think of them as a kind of diary, a skyward journal that tracks the heartbeat of the mesosphere. The clouds don't write in ink or thunder. They write in shimmer, in silence, in the choice to appear or not. In this way, Noctilucent clouds remind us that change doesn't always come with sound or spectacle. Sometimes it drifts, slowly, season to season, year to year, like a thought taking shape. So we drift with them now, through the chapters of summers past, watching their paths, tracing their arcs, listening for the quiet message they may carry. Let's follow that message back in time, to their very origin, where fire and dust gave rise to frost and light. And so we begin. Every night, Earth is brushed by meteors, tiny grains of space rock burning quietly as they enter our atmosphere. And most go unnoticed, a brief streak, a flicker, then gone. But what they leave behind lingers. Noctilucent clouds are born not just of cold and moisture, but of these vanished visitors. When a meteor burns up high in the atmosphere, it leaves behind a trail of fine particles, invisible dust, scattered like seeds. In the mesosphere, these particles become the starting point for something rare and beautiful. They are the nuclei, the tiny anchors around which water vapor can freeze. Without them, there would be no surface for ice to cling to, no shimmer to emerge. In this way, Noctilucent clouds are a kind of echo, a soft reminder of something that fell, flared, and faded, a memory suspended in twilight. Meteoric smoke, as scientists call it, spreads across the upper atmosphere. It drifts for days, even weeks. And when conditions align, when the temperature drops low enough and water vapor is present, crystals form, tiny, delicate, floating in silence. The result is a veil of light that moves with the winds of the upper atmosphere, tracing long arcs, shifting like breath across the polar sky. These clouds are not born of storms. They are born of collisions, of energy met with resistance, of space meeting air. And yet, the result is not noise or chaos, but serenity, not fire, but frost. There's something poetic about that a violent entry, a fragment of rock meeting Earth's shield, can lead in time to the softest light in the sky. It reminds us that transformation is not always immediate, that even the most dramatic events can give rise to something gentle, given time. So, as we watch these clouds drift, overhead, we are also watching the remains of something much older. A journey that began in the darkness of space, ended in a brief flash, and was reborn in ice. Noctilucent clouds are a convergence of Earth and cosmos, of past and present, of heat and cold. And in their silver blue light, we find a story written not in words, but in reflection. Let's stay with that glow a little longer, because the sky still has more to tell. Sometimes, when the sky is still and the moon has risen, something extraordinary happens. A shimmer, pale and soft, appears just above the horizon, not from the sun, but from the moon itself. Noctilucent clouds, though best known for catching the last light of day, occasionally glow under moonlight too. It's a gentler glimmer, fainter, more elusive. But when it happens, the result is breathtaking in the quietest way. Tonight, we'll drift into that soft light. The moon, casting its silver gaze across the earth, becomes a companion to these high, icy clouds. While sunlight at the edge of night paints them blue and white, moonlight cloaks them in a dim, pearly sheen, like soft reflections on water, only far above our heads. The interaction between noctilucent clouds and moonlight is subtle. It happens only when the moon is bright enough, typically near full, and positioned just right below the horizon. The mesosphere, where these clouds reside, must still be sunlit, even while the land below rests in night. That perfect alignment allows the moonlight, reflected sunlight itself, to softly illuminate the crystals suspended high in the atmosphere. Because moonlight is far dimmer than sunlight, these lunar reflections are delicate and easily missed. It takes very dark skies to see them, free from city lights, with clear conditions and a wide view of the horizon. Those who do witness them often describe the moment as dreamlike, a brush of glow, a feather of shimmer, a feeling almost more than a sight. These rare events offer something special, a second chance to see the clouds glow. While most noctilucent sightings occur shortly after sunset or before sunrise, moonlit appearances can extend that window, letting night linger just a little longer in silver light. To imagine such a night, picture yourself beneath a quiet sky. The moon is nearly full, casting gentle shadows across a sleeping landscape. The stars are faint, dimmed by the moon's presence, but still watching, and there, barely visible, a soft glimmer ripples across the upper sky. It doesn't flash or flicker, it drifts, it shimmers, it whispers. The glow may appear as a thin veil, a ripple, a faintly glowing thread of silver blue. It may stretch across the horizon or rest in a single patch, but no matter its shape, it carries a presence, something between dream and reality. In these moments, the earth feels both vast and intimate, the moon above, the clouds beyond, and you, small and still, simply watching. There is no urgency here, no need to name or capture the sight, just quiet appreciation, just stillness. Noctilucent clouds remind us that beauty does not always shout. Sometimes it glows, softly, silently, with the light of a moon that itself reflects the light of a sun that has already gone. So tonight, as you settle beneath your own sky, consider the moon. Look gently toward the horizon, and if the moment is right, you may just see a glimmer, a quiet glow in the upper air. Sleep well under the shimmer of moonlit clouds. They both appear near the poles. They both dance in twilight. They both seem like magic. But noctilucent clouds and aurora borealis are not the same. One is born of ice crystals, the other of charged particles. One drifts slowly, silently, the other pulses with energy. Tonight, we'll drift softly between them, comparing not to divide, but to understand the unique poetry of each. Auroras are a spectacle, often vibrant, occasionally dramatic. They light up the sky with movement and colour, greens, purples, pinks, waves, and curtains that ripple across the firmament. Caused by solar particles colliding with gases in the Earth's upper atmosphere, they are a visual song of space weather, written in light. Noctilucent clouds are quieter. They glow faintly, often barely visible. Their colour palette is cool and restrained, silvers, soft blues, hints of white. They appear in stillness, not motion. Formed from microscopic ice crystals clinging to high-altitude dust, they drift like sky feathers across the edge of night. Yet, both remind us to look up. Both inhabit realms beyond the weather we know, far above rain and wind, beyond the reach of most clouds. Auroras shimmer in the thermosphere, even higher than noctilucent clouds, which reside in the mesosphere. Together, they bracket the sky in wonder. Auroras are often accompanied by geomagnetic activity, storms from the sun that disturb Earth's magnetic field. Their arrival can be predicted, tracked, even chased. People travel to see them. Alerts are issued. Hope builds. Noctilucent clouds offer no such fireworks. They appear without warning. They do not follow flares or storms. Instead, they wait for perfect alignment. A high-altitude chill, the presence of water vapor, a scattering of dust, and just the right angle of light. They ask nothing of us but stillness. And so, while auroras call to the adventurous, noctilucent clouds invite the contemplative. One wakes us with awe, the other lulls us into peace. There are moments, very rare, when both appear in the same sky, when solar wind and mesospheric ice share the twilight. It's a layering of light, a duet of sky phenomena, but more often they take turns. In comparing them, we learn more about what makes each special. The aurora is firelight. The noctilucent cloud is moonlight on frost. One dances, one drifts, and both, whether pulsing with cosmic energy or glowing with delicate ice, remind us that the upper sky is not empty. It holds stories, movements, lights that whisper of things beyond our world. So tonight, imagine yourself in the high latitudes, standing still, eyes up. Perhaps you'll see the aurora's wild flame, or the noctilucent cloud's silver hush. Either way, you'll be looking into the poetry of the heavens. They don't last the whole night. As the sun dips deeper below the horizon, the angle fades and they vanish. We'll float through that transition, soft and slow. As twilight begins its slow retreat, and the sky deepens into darkness, a quiet transformation unfolds above. Noctilucent clouds, those faint, shimmering veils suspended in the mesosphere, begin to disappear. Not with a dramatic exit, but with a whisper, fading slowly from view. These clouds are only visible during a specific window of time, when the sun has slipped just below the horizon for us, but still shines high enough to illuminate the upper atmosphere. It's a delicate alignment, a cosmic balancing act between shadow and light. Imagine the Earth turning gently, the sun continuing its descent. As it drops farther below the horizon, beyond about 16 degrees, the sunlight no longer reaches the mesosphere at the right angle. The high, icy clouds, once bathed in silvery blue light, are left in darkness. And with that, they vanish. If you've ever watched them slowly dim, you'll know the feeling. One moment, they hover in a soft, glowing stillness. The next, they begin to lose their luster. Not all at once, but in a slow dissolving, like fog lifting from a quiet field. The timing of this vanishing act varies slightly, depending on your latitude and the season, but generally, noctilucent clouds are best seen within an hour or two after sunset, or just before sunrise. Beyond those gentle windows, they slip back into invisibility, hidden high in the thinning air where light no longer reaches. In this chapter, we rest in that tender moment when light lets go. We imagine the transition as not just a shift in brightness, but a soft passage, a changing of the sky's breath, a reminder that everything, even the most delicate cloud, has its time. Some skywatchers call this the closing of the noctilucent curtain. It's a fitting image, like the final hush at the end of a dream, like the stars gently reclaiming the sky. And so we drift there now, beneath a sky that darkens slowly as the last glow of high-altitude clouds fades into the backdrop of night. We don't rush it. We simply observe, breathing with the rhythm of the turning earth. letting the moment pass as all beautiful things do. When the clouds are gone, the sky remains. Deep, quiet, still. A canvas now turned over to the constellations, and in their place, perhaps, a memory lingers, of silver tendrils once glowing against dusk, of something faint and far away, of beauty, briefly seen, then softly released. In this chapter, we imagine dreams rising that high, thoughts drifting 80 kilometers up, a poetic reflection on how cloud and mind both wander. Let's drift together into a space not bound by earth or stars, but something in between. A space where the air is too thin to carry sound, but not too empty to cradle beauty. The mesosphere. Here, noctilucent clouds form, light as whispers, high as hopes. And in this high and hushed region, it's easy to imagine something else rising too. Thoughts, dreams, the soft stirrings of the mind at rest. Imagine, for a moment, your thoughts becoming lighter, less burdened, released from the pull of the day, each one a vapor floating upward, climbing past rooftops, through the troposphere, beyond the weather we know, and into the mesosphere. It's a quiet journey. The world below fades, softened by distance. The mind loosens, untethered by urgency. Up here, there are no demands, only the spaciousness of a sky between earth and space, where clouds shimmer without weight. Noctilucent clouds are born of icy crystals and meteor dust, tiny seeds scattered by falling stars. And perhaps dreams are like that too, fleeting, formless, sparked by the distant, the quiet, the half-remembered. We don't need to define them, only to observe them. Let them drift. Let them form shapes of their own, like silver patterns against a darkening sky. In the mesosphere, the clouds never fall. They simply appear, glow for a while, and then dissolve. How much like a dream that is. And while we may never truly visit this layer, never feel its touch or hear its silence, we can reach it in other ways. In wonder, in stillness, in the gentle hush of night. Tonight, as you lie back and listen, imagine your thoughts as cloud particles, moving slowly, suspended in the quiet. Maybe they take the form of memories, of soft questions, of things not yet known. Maybe they drift without form at all, content simply to float. And maybe, for a while, you'll find yourself there too, among the glowing clouds, in a sky that neither holds nor hurries, where nothing is urgent, where silence is a comfort. In the mesosphere, there is no rush, only presence, only softness. So we'll rest here just a little longer, breathing slowly, held by altitude and by imagination, half asleep, half awake, and gently, gently drifting. Even with all our instruments and satellites, even with decades of careful observation and thoughtful study, there is still so much we don't yet understand about noctilucent clouds. Their mysteries are soft-spoken, lingering at the edge of certainty, just out of reach, like a shimmer seen through sleep-blurred eyes. Tonight, we'll drift gently into the unknowns, not to solve them, but to rest beside them, to sit, as it were, in the quiet space where questions live. Noctilucent clouds, for all their beauty and delicacy, continue to puzzle scientists in subtle ways. Why do they appear more frequently now than they once did? Are they truly becoming more common? Or is it simply that more people are watching the sky with curious hearts and better tools? One theory suggests that increases in atmospheric water vapor, perhaps from human activity or natural changes in climate, may be contributing to more frequent formation. Others note that rocket launches and satellites could play a role, injecting particles into the upper atmosphere, sometimes unintentionally seeding the clouds. But none of these ideas are complete. None of them explain everything. Even the question of how long a single noctilucent cloud persists remains something of a mystery. From the ground, they appear to form quickly and vanish just as fast. But above, in the mesosphere, the motions are more complex, woven from high-altitude winds and invisible waves. Do these clouds ripple across the globe, unseen? Do they linger beyond the reach of human eyes? Then, there are the questions of what they truly signify. Are they a sign of change, a gentle signal of shifts in our atmosphere? Or are they timeless, ancient formations that have only now begun to whisper to our modern instruments? Some scientists believe Noctilucent clouds may serve as a kind of mirror, reflecting conditions in the middle atmosphere with surprising sensitivity. Others believe we're only beginning to understand their language. And so we drift among these unanswered questions, not in urgency, not in need of resolution, but in peaceful curiosity. In the world of science, mystery is not a failure. It is an invitation, an opening, a space to wonder. In the hush of this chapter, we allow ourselves to rest in not knowing, to breathe in the beauty of something still unfolding. Like twilight itself, it is a moment of in-between, a threshold between understanding and awe. And if some part of you is still awake, still listening, you might carry one of these quiet questions with you into sleep, not to solve it, but simply to hold it, to let it float in the space between dreams, soft and silver, like the clouds that inspired it. And now, dear listener, we've reached the final edge of our dreamy ascent. One last glance skyward, one final shimmer of silver blue above the horizon. The noctilucent clouds, once glowing like threads of moonlight stretched across twilight's canvas, are beginning to fade. The sun, now deep below the horizon, can no longer cast its angled rays upon them. The geometry has shifted. The angle is gone. The glow dissolves. This chapter is a farewell, but a soft one. Like the clouds themselves, our goodbye is delicate, drifting, unhurried. We watch together as the silver veil melts into the darkening sky, the shapes losing their outline, the brightness yielding to night. Imagine standing beneath that vast sky, the stars beginning to appear as the last noctilucent tendrils quietly vanish. A cool breeze stirs the grass. The air smells faintly of dusk and distance. Above, only memory remains, a trace of silver, now tucked away in the folds of night. These clouds will return, of course. They always do. In seasons yet to come, under twilight skies, they'll shimmer once more. But for now, we release them. Let your breath slow, like light receding from the sky. Let your body sink into comfort. You've traveled high tonight, to places most never see. The edge of weather, the edge of space, the edge of sleep. As the silver clouds disappear, we return gently to earth, carried not by urgency, but by rest, by quiet wonder, by the soft exhale of a story coming to its end. Thank you for drifting through this journey. Good night, peaceful dreams, and calm, silver skies to you. And as our gentle exploration of noctilucent clouds draws to a close, I hope you found peace in their quiet shimmer and comfort in their rarity. May the soft silver light we trace tonight linger in your thoughts, cool, weightless, serene. Even though these clouds appear only for a brief moment at twilight, the calm they bring can last much longer. Let this journey stay with you, like a hush in the upper sky. Let it cradle your breath. Let it soften the edges of your day. If you'd like to return for more, calming weather journeys, you're always welcome here. Feel free to subscribe if it feels light and easy, like drifting on a high breeze. There's no pressure, just a soft invitation to come back when you need rest. But for now, there's nothing more to seek. No more facts, no more clouds to chase, only stillness. Let your thoughts float like ice crystals. Let your body grow weightless. Snuggle in. Good night. Peaceful dreams. Calm skies to you.